Hi everyone, I'm going to go over figure 4 from our article about SARS-CoV-2 and basically how that is able to infect our cells. So first, I want to give just a little bit of background. So when a virus is able to infect our cells, first it needs to bind, and that they already showed in this article to be important for ACE2. So ACE2 is the receptor. However, binding to the receptor isn't enough. The virus can be attached but just still out here on the cell surface unless it is able to get its viral genome inside the cell. So there are two ways this can happen. One is the direct pathway, where something on the cell surface actually causes fusion of the two membranes, the viral membrane and the cell membrane, and that allows the viral genome to enter. Or the indirect pathway, where after binding for a while, endocytosis is triggered, and this is just a natural cell phenomenon where it's endocytosing something and often sending it to the lysosome for degradation. So if the virus wants to infect the cell and not be degraded, it needs to cause fusion here. And the fusion through the indirect pathway is known to be done by CAT-BL, that enzyme that will cause fusion here to allow the viral genome in. And what this figure is showing us is that the COVID-19 virus can actually use TIMP PRSS2, that enzyme, to cause fusion through the direct pathway as well. So basically what they're using at first is pseudovirus particles, and these are important because these are virus particles that you can engineer to have different membrane proteins on their surface that you want to study, but they're also much safer because they're lacking the viral genome and therefore they're non-replicative. So you'll often see these used first and then the full virus used to confirm later. Another key thing here is that they're using vero cells, and if you remember back from figure 1, the vero cells are a monkey cell line, but the importance here is that this is a cell line that we know our viruses, our SARS viruses, infect. Right? But importantly, vero 1 cells do not express TMPRSS2. Right? So therefore they do not have the potential for the direct pathway and must be using the indirect pathway, and that's shown here in figure 1. So in figure 1, when you use E64D, which blocks the CAT-BL indirect pathway fusion, you can see that you prevent the virus from getting in. Camostat doesn't do anything, and that makes sense because these cells don't express TMP, but then put them together and again it works. And here we see our control. This is the VSVG. This is actually the VSV particles that have the glycoprotein that can infect any cell. So this is our positive control, and this is really important because we want to make sure that under all conditions these virus particles are able to get in the cell. Because if you just saw inhibition, there's two possibilities. The one that we hope for is that inhibiting that pathway prevented viral infection. That's the conclusion we want to make. But it could mean that whatever drug we've used, whatever our cell conditions we've done, has just killed the cells, in which case no virus can enter. So if the positive control is still working, that means our system is working, and this inhibition is real and specific to that enzyme. So again, we see here that obviously COVID-19, as well as the old SARS, can use the indirect pathway. However, when you make the vero cells express TMPRSS2, now it shows they can use that direct pathway as well, because now when you use the E64 inhibition, virus still gets in. When you use Camostat, it's inhibited, but not all the way. When you put them together and inhibit both the direct and indirect pathway, they're both, the virus entry is inhibited. Then they go a little bit further. Now they're using T293T cells, and these are just a cell line that is used often, and they can transfect it with whatever. So they've made it express our receptor so that the virus can get in. These do not normally have TMP, and in the absence of TMP, our CAT-BL inhibitor can inhibit the virus from entering. But as soon as you add TMP, now it doesn't matter if you give the CAT-BL inhibitor because it's getting in through the direct pathway. So the take-home message is that's here is if the cell expresses TMP, both the old and new COVID viruses will use that to prime and allow viral entry. Then they go on and they test this in lung epithelial cells. This is a cell line. And they just see if this Camostat, this inhibitor of TMP, can effectively block viral entry and maybe be useful for inhibitor, an antiviral inhibitor. And you can see here they just add different doses of drug, and in doing so they found that the EC50 is 1 micromolar, the EC90, where 90% is blocked, is 5 micromolar, and so you can see that dose dependency. And here again we see our positive control is working, so this is due to the drug and we haven't killed the cells or anything like that. Then they just go a couple steps further, and now they wanted to find out if this is true using the full COVID-19 virus. And here, this is interesting. This is the inoculum. So this is how much virus they're adding. At 0 hour, they haven't added virus, so this is our negative control baseline where the cells shouldn't be expressing any of the viral particles. And then here, after 24 hours, when we've added those, you can see that not only in our control do we have this same level here, but we have more. This means the virus particles are actually replicating. The cells are making more. And then when we add our TMP inhibitor, we've brought this back down here. And there's two key aspects to this. This is a log scale, so this is actually a 100-fold difference, so it's a pretty huge difference, and this brings us back to our original inoculum. So the cell virus is not replicating along the way. And then finally, they just really want to make sure this is clinically relevant, so they use a primary lung epithelial cell. And you can see again in the primary lung epithelial cell, these are the cells that the virus will be naturally affecting in your body. The camostat does indeed inhibit viral entry. And the take-home message then is that COVID-19 appears to use TMP for fusion and viral entry, and therefore that inhibitor, the camostat inhibitor, might be a good and valid antiviral option. Thank you.